हेलो एंड वेलकम अगेन। सो कुछ दिन पहले सीएसईआर नेट में एक क्वेश्चन आया था क्वांटम मैकेनिक्स से एंड द क्वेश्चन इज फॉर अ गिवन क्वांटम स्टेट psi of L and M where L was equals to 4 and M was also equals to 4 and हमको ये बताना था what is the uncertainty in L of X. Okay, Lx is the component of angular momentum. Okay, now so delta Lx. So delta x, as we know, it's a standard deviation of Lx. Okay, and in quantum mechanics, we called it the uncertainty. So delta L of x equals to under root of mean square of Lx, that is written as like this. So it's the mean square of Lx minus square of mean of Lx. Okay, so this first one is the mean square of Lx, mean square of Lx, and this one is the square mean of Lx, square mean of Lx. Okay. S- Okay. Now let's look at these two terms separately. So first, let's look at this term. So it's the square mean of Lx. So this term we're actually first of all solving. Okay. So first one is the square mean of Lx. So this term. So this term is square mean of Lx. Okay. Now for orbital angular momentums, this is equals to Ly square. It's equals to 0. Okay. For any kind of momentum operators, this is what holds true. Okay. So this will always be equals to 0. So we don't have to worry about this term. Now the remaining term is this mean square of Lx. So this is the remaining term. Now it turns out for momentum operators, we have one more relation. So Lx square this. So mean square of Lx equals to mean square of Ly, and this is equals to h square by 2 L into L plus 1 minus M square. So this is what holds for momentum operators. Okay. Now if you plug in the value of L and M, so here L equals to 4 and M equals to 4. So we have Lx square, mean Lx square equals to h square by 2. Then L is 4, 4 plus 1 minus 4 square, which will be, if we evaluate it, so we'll get 2h square. Okay, so we got both the terms. The first term, first term here is actually 2h cut square, and second term is 0. Okay, so second term is actually 0. Then what will be our uncertainty? Our uncertainty will be simply written as under root of twice h cut square, which equals to root 2 h cut. Okay, so this is our answer. One question in this recent exam was from electrodynamics, and the question was, given electric field E equals to E naught sine of kz minus omega t in the direction of j cap, find the Poynting vector S. Okay, so as we know, S equals to 1 by mu naught E cross B. So this we know. Okay, so this is the Poynting vector that we had find, and we can use this relation that C equals to under root of epsilon naught mu naught, or you can write Poynting vector also like epsilon naught C square E cross B. Okay, so this is the Poynting vector that I had to find. Now let's look at the electric field. So electric field that is given, so E equals to E naught sine of kz minus omega t j cap. Okay, so let me draw the axes. So So these are my axes. So this is suppose x-axis. So this is the y-axis, and this is the z-axis. Okay. Now the wave is propagating in the z direction, as is evident from this term kz. So it means the wave is propagating in the z direction, and the electric field is in j cap direction. So electric field, let me draw it like this. So electric field is in this direction, j cap direction. Okay, so this is my electric field. Now, if the wave is propagating in this direction, z cap direction, so this is suppose propagation direction k, then magnetic field obviously should be in the downward direction. So magnetic field should be in the direction of minus x cap. So this should be the magnetic field direction of magnetic field. Okay, and here we have the 90-degree. Okay, so if electric field is given, so we can also write the magnetic field, because we know the relation that uh, magnitude of magnetic field is given as like this relation, magnitude of E divided by C. Okay, so we can easily write magnetic um, vector, that will be E by C. So magnitude of electric field, that is E naught divided by C, with the same phase. So sign, so phase are same. So when a light propagates in any medium, uniform medium, phase remains same. So kz minus omega t, but the direction is now in the direction of minus I cap. So I will write minus I cap. Now that I have both the electric field and magnetic field, I can simply do the cross multiplication between these two vectors to find my Poynting vector. So S will be equals to epsilon naught c squared. So when we multiplied, I'll be having E naught and E naught by C. So it will be E naught squared by C. So one C will get cancelled out. So it will be only C in the numerator. Then it will be sine square of kz minus omega t, and then I will have j cross minus I cap. So j cross minus I cap. So j cross minus I cap will be in the direction of z. So I'll write k cap simply. Okay. So this is my Poynting vector.